Hello again, everyone, and welcome to our math class. Last meeting class, we talked about arithmetic sequence, and we have mentioned that arithmetic sequences are formed by addition. The second type of sequence that we will be learning is what we call a geometric sequence, and geometric sequences are formed by multiplication. That means to say that each term in a geometric sequence is found by multiplying the previous term by the same number. An example of a geometric sequence is 1, 2, 4, 8, 16, and so on. Note that each term is multiplied by 2 to get the next term. Thus, the next three terms are 16 times 2, which is equal to 32. 32 times 2, which is equal to 64. And 64 times 2, which is equal to 128. This also implies, class, that 2 is the ratio common to each pair of consecutive terms. That is, 2 divided by 1 is equal to 2, 4 divided by 2 is equal to 2, 8 divided by 4 is equal to 2, and so on. This is why the constant multiplier in a geometric sequence is called the common ratio. The small letter r, class, is used to denote the common ratio. Let us try our first example. Find the common ratio and the next three terms of the geometric sequence 6, 12, 24, 48, and so on. To find the common ratio, divide the second term by the first, or the third by the second, or the fourth by the third, and so on. Hence, we have 12 over 6, or 24 over 12, or 48 over 24, and so on, which is actually equal to 2. Therefore, our common ratio is 2. The next three terms are 48 times 2, which is equal to 96, 96 times 2, which is equal to 192, and 192 times 2, which is equal to 384. Let us try our second example. Find the common ratio and the next three terms of the geometric sequence 1 all over 2,500, negative 1 over 500, 1 over 100, and negative 1 over 20. To find the common ratio, divide the second term by the first, or the third by the second, or the fourth by the third, and so on. Hence, our common ratio is equal to negative 5. The next three terms are negative 1 over 20 times negative 5, which is equal to 1/4. 1/4 times negative 5 is equal to negative 5 over 4, and negative 5 over 4 times negative 5 will give us 25 over 4. In general, the terms of a geometric sequence is of the form a sub 1, a sub 1 times r, a sub 1 times r squared, a sub 1 r cubed, a sub 1 times r to the fourth, and so on until a sub 1 times r raised to n minus 1, where a sub 1 is the first term, n is the number of terms, and r is the common ratio. So to summarize class, a sequence with a common ratio is a geometric sequence. The nth term, a sub n, of a geometric sequence is given by a sub n is equal to a sub 1 times r raised to n minus 1, where a sub 1 is the first term, r is the common ratio, and n is the number of terms. I would like you also to remember, class, that a geometric sequence with a definite number of terms is referred to as a finite geometric sequence. Examples of finite geometric sequences are the following: 1, 5, 25, 125, and 625. We also have 32, 16, 8, 4, 2. Or another example is 1, 10, 100, 1,000, and 10,000. On the other hand, a geometric sequence with indefinite number of terms is described as an infinite geometric sequence. Examples of infinite geometric sequences are the following: 80, 40, 20, 10, 5, and so on. 1 half, 1 sixth, 1 18th, 1 54th, and 1 over 162, and so on. We also have 0.8, 1.6, 3.2, 6.4, 12.8, and so on. Let's have our third example. Write the first 5 terms of a geometric sequence where the first term is equal to 8 and the common ratio is equal to 3. To get the first 5 terms of the geometric sequence, we have to multiply the preceding term by r to get the succeeding term. Therefore, we have the second term, which is equal to 8 times 3, and that's equal to 24. The third term is equal to 24 times 3, which is equal to 72. The fourth term is 72 times 3, which is equal to 216. And the fifth term is 216 times 3, which is equal to 648. Therefore, the first 5 terms are 8, 24, 72, 216, and 648. Let's solve our fourth example. Find the 11th term of the geometric sequence -40, 20, -10, 5, and so on. The given geometric sequence has first term which is equal to -40, and the common ratio r is determined in the following manner. R is equal to 20 over -40, which must be the same as -10 all over 20, and which is also the same as 5 over -10. And that gives us an answer which is equal to what? -1/2. Consider n to be equal to 11. Substitute a sub 1 equals -40, r is equal to -1/2, and n is equal to 11 for the formula for a sub n, which is a sub n is equal to a sub 1 times r raised to n minus 1. Therefore, we have a sub 11 is equal to -40 times -1/2 raised to 11 minus 1. Or we have -40 is times -1/2 raised to the 10th power. And we know that -1/2 raised to the 10th power is the same as 1 all over 1024. And that has to be multiplied to -40, giving us therefore a sub 11 value which is equal to -5 all over 128. Hence, the 11th term is -5 all over 128. In example number 4 class, the geometric sequence is -40, 20, -10, 5, -5 over 2, 5 over 4, -5 over 8, 5 over 16, -5 over 32, 5 over 64, and -5 over 128. The terms between -40 and -5 over 128 are the geometric means. These are 20, -10, 5, -5 over 2, 5 over 4, -5 over 8, 5 over 16, -5 over 32, and 5 over 64. Geometric means, therefore, are the terms between any two given terms of a geometric sequence. On that note, let us try our fifth example. Find the three geometric means between 32 and 1/8. The geometric sequence appears like this, where a sub 1 is equal to 32, a sub 5 is equal to 1 over 8, and n is equal to 5. To find the common ratio, substitute these values to a sub n is equal to a sub 1 times r raised to n minus 1. So we have 1/8 is equal to 32 times r raised to 5 minus 1, which gives us 1/8 is equal to 32 r raised to the fourth power. Simplifying it, we have 1 over 256 is equal to r raised to the fourth power. And we know that 1 over 256 can be expressed as 1/4 raised to the fourth power. So we have 1/4 raised to the fourth power is equal to r raised to the fourth power. Now, since their exponents are the same, we could now equate the bases. So r is equal now to 1/4. If r is equal to 1/4, then the second term is 32 times 1/4, which is equal to 8. The third term is 8 times 1/4, which is equal to 2. And the fourth term is 2 times 1/4, which is equal to 1/2. Therefore, the three geometric means between 32 and 1/8 are 8, 2, and 1/2. So class, a term between two terms of a geometric sequence is called a geometric mean, or more specifically, it is called mean proportional. If a sub 2 is the mean proportional between a sub 1 and a sub 3, then by definition of a geometric sequence, we have a sub 2 all over a sub 1 must be the same as the quotient of a sub 3 and a sub 2. By cross multiplication, we have a sub 2 squared must be equal to a sub 1 times a sub 3. Extracting the square root of both sides, we have a sub 2 now, which is mean proportional, is equal to positive negative square root of the product of a sub 1 and a sub 3. Therefore, the mean proportional between two numbers is equal to the square root of their product. To illustrate the definition, class, let's try to look at the sixth example. Find the mean proportional between 3 and 12. We let m be the mean proportional. So m must be equal to positive negative square root of a sub 1 times a sub 3, which in this case are 3 and 12 respectively. So we have m, which is the mean proportional, is equal to positive negative square root of 3 times 12, which is the same as positive negative square root of 36, which is also the same as positive negative 6. Therefore, the mean proportional between 3 and 12 are positive 6 or negative 6. Let's try to look at the seventh example. Find the mean proportional between negative 2 and negative 12. Again, we let m be the mean proportional. So we have m is equal to positive negative square root of a sub 1 times a sub 3, which in this case are negative 2 and negative 12 respectively. So we have m is equal to positive negative square root of negative 2 times negative 12, which is equal to positive negative square root of positive 24, which when simplified will give me positive negative 2 square root of 6. Therefore, the mean proportional between negative 2 and negative 12 are positive 2 square root of 6 or negative 2 square root of 6. Using the concept of mean proportional, we try to solve example number 8. The second term of a geometric sequence is 1 and the fourth term is 9. Find the first and 10th terms of the sequence. Between the second and fourth term is their mean proportional, which is positive negative square root of 1 times 9, which is equal to positive negative 3. The common ratio R is taken by dividing the third term all over the second term, or that gives me positive negative 3 all over 1, which is also equal to positive negative 3. Therefore, a sub 1 is taken by dividing the second term by the common ratio, which gives us 1 all over positive negative 3, which is equal to positive negative 1/3. And the 10th term is a sub 10 is equal to positive negative 1/3 times positive negative 3 raised to 10 minus 1. Or that gives me positive negative 1/3 times positive negative 3 raised to the ninth power. Or that simplifies to positive negative 1/3 times positive negative 19,683, which gives me now an answer of 6,561. Before I end class, may I just acknowledge this reference. And that ends our discussion on geometric sequence. Be safe, be healthy. I'll see you in my next videos. Until then,